All right, friends, welcome back. In this video, I'd like to go ahead and take a first day for section 1.6 of your textbook, and this is actually going to be part 1 of day 1. You can also find part 2 in the exact same Schoology folder for you. But yeah, we're going to go ahead and take this one in parts, because what 1.6 is all about is how to solve various types of equations, and I think it's just better and easier for us if we just kind of devote one little video to each of the types of equations that we're going to solve, just so that you can refer back to whichever one you need in the future. So in this video specifically, we are going to take a look at polynomial equations, okay? In the remaining videos that we are going to cover here in section 1.6, we're going to talk about all these different other ones, like rational equations, absolute value equations, and radical equations. But in this one, like I said, we're going to focus specifically on polynomial equations, which the steps for those are right here, okay? So just to kind of describe these here really quickly, one of the first things that you need to make sure that you have in your equation is you need to collect all of your terms to one side and leave equals 0 on the other side of your equation, okay? And that's going to be very, very important for us to be able to go ahead and do what it says in step 3, which is to set each of your factors equal to 0 and solve. We wouldn't be able to do that if we didn't do step 1. And then step 2 in the between says to go ahead and factor if you can, if it's possible. If it's not possible to factor, then we're just going to go ahead and use quadratic formula to solve, okay? Now, one of the things that we are going to definitely need to make sure that we are aware of how to do today is to do this factorization step if it comes up, okay? And so just to kind of help us remember how to factor, I've gone ahead and left a copy of your factoring checklist over here off to the side. Definitely one of those things that we need to kind of make sure that we know how to go through. In this video specifically, I'm going to assume that factoring is something that you know how to do. If that's not the case, you might need to go back to some of those chapter P videos where we first talked about how to factor and just kind of brush up on that before you continue with this video here, okay? But in this video specifically, we are especially going to be using a lot of these different factoring formulas that we talked about. So the difference of two squares, the sum of two cubes, the difference of two cubes, those are going to pop up here. Let's go ahead and take a look at some of those examples. So to save time in the video, I've already gone ahead and worked out a couple of these. So let's just take a look at numbers 1 and 2 here, right? So in numbers 1 and 2, you'll notice that in number 1, they already collected all the terms to one side, and they got your equals 0 for you, so that's pretty nice. What we would then need to do is just go ahead and simply factor, and so that would be a trinomial that we would go ahead and factor into x plus 1 times x minus 8, and then here's where we would go ahead and use the zero product property, right? So each one of those individual factors we would set equal to 0 and solve, and we would get x is equal to -1 and x is equal to positive 8. That's not the first time we've done an example like that, so we're just kind of reviewing there. Number 2, if you bring that -2 over to the other side, you would have a polynomial that reads x squared minus 6x plus 2 equals 0. So remember to get that equals 0 in the mix. And that is actually a polynomial that does not factor nicely for you. So you see there that I've gone ahead and used the quadratic formula, and I was able to get these two answers here. So I have 3 plus the square root of 6, and then separately I have 3 minus the square root of 6. Those are my two solutions of that equation, okay? And so again, we've done questions like that in the past, so this is just a little bit of review here. In number 3, you'll notice that we have our first factoring formula coming into play. So we have something that looks like x squared minus 81 is equal to 0. A couple of flags there that would be a difference of two squares. First of all, I see a minus sign. I see that I have two terms on the left-hand side. I see that we have x squared, and then I see a perfect square number like 81. These are all flags to tell you that this is going to be the difference of two squares here in this problem. And so if I go ahead and factor it as a difference of two squares, I see that just factors into x plus 9 times x minus 9, and then zero product property tells me what my 0 should be, okay? So those first 3 examples, those should be some pretty straightforward review of stuff that we've done relatively recently. What I want to spend some more time working on are some of these following examples, like number 4 here, where it says x to the 4th minus 2x squared minus 3 is equal to 0. So that is not a quadratic function, but it is something that you can rewrite as a quadratic, okay? So specifically, if I were to go ahead and rewrite it as a quadratic, like something squared minus 2 times that same something minus 3 is equal to 0, then that something that I'm referring to, of course, is just simply going to be x squared. And again, we've taken a look at examples like this back in our factoring videos, so maybe you want to go ahead and review that. But if we could write it as a quadratic like this, then that means that we can factor it as if it were a quadratic. So I could write the product of two binomials in this way is equal to 0. And then I would be looking for two numbers that multiply to make -3 and add to make -2. Those two numbers, of course, would be a +1 and a -3, I believe. And then instead of saying our just variable x, here's where we would go ahead and say x squared is playing the role of our variable here, okay? And then when we go ahead and perform the zero product property, we would just set each one of these equal to 0 individually and solve. So x plus 1 is equal to 0, and x x squared plus 1 is equal to 0, x squared minus 3 is equal to 0. And then we would solve these individually. So if you subtract 1 from both sides of that equation and add 3 to both sides of this one, we would end up with these results here. And then if you were to take your plus or minus square root of both sides, which of course, remember, anytime you introduce a square root to the problem, you're going to have to introduce that as a plus or minus square root. We would end up with the following here. So x is equal to plus or minus the square root of -1, and x is equal to plus or minus the square root of 3. Okay, so those are 4 solutions, but we can clean this up a little bit because, remember, in the 1.4 video, we talked about your complex numbers, and we know that the definition of the imaginary unit I is just the square root of -1. So we can clean up our result from this left-hand equation and just simply say x is equal to plus or minus I. And then in the case of this other one, plus or minus the square root of 3, that'll be the best that we can do there. So 2 complex solutions and then 2 real solutions. In number 5, we have something that looks like x squared, x to the 4th minus 36 is equal to 0. That is something that you can rewrite as the difference of 2 squares. Specifically, what you square to get x to the 4th, of course, is x squared itself. And then what you square to get 36, of course, is 6 itself. So when we apply the difference of squares formula, which you can go ahead and say right here, that is simply just going to be plus and minus. And we would simply say here x squared plus 6, x squared minus 6. Okay? And it would be at this point that we can go ahead and split this up and then use zero product property here. So this would be x squared plus 6 is equal to 0, x squared minus 6 is equal to 0, in which case you would just solve both of these. And I'm just going to go ahead and give away the punchline for the sake of time in the video. What you would get in this equation here on the left-hand side is plus or minus I, the square root of 6. And then what you would get on the equation here on the right, that would be plus or minus the square root of 6. Okay, so again, 2 complex solutions and then 2 real solutions. Okay, so 4 solutions total. If you have one like number 6 where it says x to the 6th minus 1 is equal to 0, that is something that we can go ahead and look at as the difference of 2 cubes, right? So remember, what can we cube to get x to the 6th? We might go ahead and write that as x squared. Remember, power to power would mean that we're multiplying those exponents. So 2 times 3, of course, would give us the 6 that we originally had. And then 1, remember, that is a perfect cube number, so we could just go ahead and cube the number 1 in order to get this going on here. So if we apply the difference of cubes formula, which is sitting right there in yellow, then we would go ahead and apply it, and we would simply have the following. We would have playing the role of u is x squared, and playing the role of v is 1. And then we would have to go ahead and take u squared here. So playing the role of u, of course, is x squared itself. So if you were to take x squared, then that would simply be x to the 4th. Okay? And then we need to add on whatever u is times whatever v is. Well, again, playing the role of u is x squared. Playing the role of v is 1. So x squared times 1 would just simply be x squared. And then we would need to add on whatever is playing the role of v squared. Well, playing the role of v is 1. If we square 1, we get 1. And so we've taken our equation and written it in this way. So it seems a little bit interesting that an equation that was so short written on the page has turned into something that we would write so long on the page. But again, this is how we solve polynomial equations, is we factor and then we use zero product property, which zero product property would be the thing that we want to go ahead and use now. So let's go ahead and actually do that. So we're going to set each one of these factors equal to 0. Now this x squared minus 1, you could look at this as the difference of 2 squares itself. So that would be x plus 1 times x minus 1, just following the formula there. And then seeing there, we could use zero product property and see that we get x is equal to -1 and x is equal to +1. So those represent 2 of the solutions that we get for this equation. So 2 real solutions. And then if we go ahead and set your x to the 4th plus x squared plus 1 equal to 0 and solve, then this would be something that you could continue to go ahead and look at as in a quadratic form. We could look at this as something squared plus something else plus 1 is equal to 0. Of course, what are we squaring there? We said from before that was just simply going to be x squared. And instead of this being something that we can go ahead and factor, this is not going to factor for us, unfortunately. So what we're going to have to do is use quadratic formula. So playing the role of A is 1, playing the role of B is 1, and playing the role of C is 1. So if we go ahead and actually go through quadratic formula and solve this, we would see here that x squared is equal to the opposite sign of B plus or minus the square root of B squared minus 4 times A times C. And then this is all going to be over 2 times A, which again is 1. Okay? So that discriminant on the inside there, if you were to go ahead and figure that out mentally, that would be 1 squared, which is 1, minus 4 times 1 times 1. Well, that's just 4. So 1 minus 4, of course, is going to give you a -3 for your discriminant. And so we would scratch out the negative underneath and write an I out front, and then our final result here would be x squared is going to be equal to -1/2 plus or minus. Sorry, actually, let's just go ahead and write it out as one fraction. So -1 plus or minus I times the square root of 3 all over 2. But keep in mind, that's what x squared is equal to. We want to figure out what x is going to be equal to here, and so what we are going to need to do is apply a plus or minus the square root of both sides of this equation. Okay, so our final answer here is going to be x is equal to plus or minus the square root of -1 plus or minus I times the square root of 3 all over 2. That would be something that we would have to rationalize the denominator on, so remember that we can do that by taking the top and the bottom here and multiplying times an extra copy of the denominator, and so that is going to give us the following as our final result. So x is equal to plus or minus the square root of -2 plus or minus 2I to the square root of 3, and this is all over 2, and that would be our result there. So our complex solution was a little bit involved there, but that is exactly what it would be equal to. So again, if you have another example like that, very, very important that we go ahead and make sure to factor everything according to that factoring checklist that you were given back in Chapter P. Okay? And so let's go ahead and move on here, right? So a couple of other examples that look like they can be written in a little bit of a quadratic form. If you're looking at numbers like 8 and 9 here, remember that you can go ahead and write these in a quadratic form by saying something squared plus 4 times something plus 3 is equal to 0. In which case that something would simply just be x to the 1/4 power. Okay, I'm going to skip out on the rest of that because this was an example that I did in class. And again, you would just simply go ahead and take care of this in the exact same way. You would factor and use zero product property. Okay, so x to the power of 1/4, x to the power of 1/4, and then you would simply just have here plus 1 and plus 3, and then use zero product property to figure out the rest of that. Okay. In the case of number 9, you can go ahead and also write this in a quadratic form by simply saying something squared plus something minus 12 is equal to 0, in which case that something would be 1 over x. Okay, and then if you were to go ahead and factor that, I believe that you could go ahead and do that pretty darn easily by finding those numbers that were to multiply to make -12 but add to make +1. I believe those numbers would be -4 and +3, so +3 and -4. And then here we would put the variable in the blank, but remember playing the role of our variable here is the 1 over x. And when you go ahead and use zero product property here, so 1 over x plus 3 equals 0, and 1 over x minus 4 is equal to 0. One of the recommendations that I have for you is to actually clear the fraction in both of these equations before you continue. So we want to go ahead and distribute in a x times, in which case it changes these equations to 1 plus 3x is equal to 0 and 1 minus x is equal to 0, in which case you can go ahead and solve both of those darn easily, and you would get some fraction results there. So I'll save the rest of that for you to do. Moving on here in the video, we have examples here. So in number 10, this would just be a 4 term that you can factor by grouping. Okay, so we discussed how to factor by grouping back in the day, and so you'll note here that at the very end, we end up with these 3 different factors. We have x plus 1, we have x, or sorry, not 1, we have x plus 2, we have x minus 2, and then we have this trinomial factor. We have x squared plus 2x plus 4. That is not something that factors itself, so that is going to have to be something that we use the quadratic formula to go ahead and figure out. And of course, here you're going to get some complex solutions for that. So you may want to pause the screen there and try to work your way through each line of that process there. Looks like we had a difference of 2 cubes showing up. And make sure that you're aware of that, right? Here in number 11, here's another worked out example. So instead of just dividing both sides by 27 and taking a cube root, that's going to make us miss out on a couple of the different solutions that we might have here. So what we should do is bring that 64 over to the other side, get that equals 0, and then recognize here that you do have the difference of 2 cubes. And so I'm just applying the difference of 2 cubes formula. Playing the role of u is the monomial 3x. Playing the role of v is going to be 4. And so I'm just applying that formula here, and now I end up with this binomial, 3x minus 4, times this trinomial, 9x squared plus 12x plus 16 is equal to 0. This is where I would want to go ahead and set both of these each individually equal to 0 and solve. And you'll notice that in order to do that trinomial, you're going to have to use quadratic formula there, in which you're going to end up with that complex result right there. Okay? And so again, maybe just pause the video on those examples and try to work through those on your own and see if you can get those to work out, right? In the case of these last ones here, no real fancy bells or whistles here. We just need to make sure that we're going through that factoring checklist completely. And so looking for that GCF first, right? So we would maybe want to factor out a 2x in this case as the GCF in all 3 of these terms. So 2x, and that would leave behind, of course, 2x squared minus 11x minus 21 is equal to 0. And then, of course, we would need to go through and actually perform your zero product property here, right? So 2x, set that equal to 0 and solve. You would get x is equal to 0. And then this would have to be something that we could use the quadratic formula in order to solve here. And I'll go ahead and leave that for you to go ahead and do, again, just to save some time in the video here, okay? As far as this last one is concerned, right, so this is a little bit of a tricky one. So remember that we had that, that way of transferring between the radical way of writing it and the exponent way of writing it back in the day. So we had one of these rules that looked like this. If you have something that looks like the nth root of a, you could always write that as a base of a to an exponent of 1 over the index of that root. Okay, and so I'm going to go ahead and apply that rule here and rewrite this, this 7 square root of x as 7x to the power of 1/2. And the reason that I might do that is because now I can go ahead and look at this as a quadratic form to it. Okay, so 6 times something squared minus 7 times something minus 3 is equal to 0. And of course, playing the role of that something would be x to the 1/2. So just remember that whatever you're putting those parentheses, that's going to have to be the same as you go through. And again, I will leave you to find the rest of the solutions there. So remember that my complete set of notes is going to be in the content library on OneNote. I'm just going to go ahead and do a lot of these worked out examples just to kind of save some time. So you may want to go back and pause the video, work your way through a couple of those examples individually on your own. And then, of course, as always, let me know if you have any questions. So thank you very much for your attention, and I'll speak to you in the next one.